Okay. All right. Welcome everybody. Thank you for the people joining us in this first seminar of the Women Water Nexus and the Education Council of the American Society of Civil Engineers. We are very happy to make this happen. We're very happy to join or to bring together these three amazing group of people that will be presenting and moderating today. So I'm gonna start sharing or introducing my colleague and also friend, Dr. Henry. She's an assistant professor in the university, Brandon University in Canada. And she's gonna guide the rest of this seminar with two amazing speakers that I know you're gonna love so much. So thank you all for being here, and I am just giving the word to Dr. Henry.
Thank you so much for that lovely introduction, and welcome everyone to the Global Science Exchange series, where we will be talking about climate crisis from understanding to action. And our first speaker is Ishrat Dollan. So Ishrat received her Bachelor of Science in Water Resources Engineering from the Department of Water Resources Engineering at Bangladesh University of Engineering and Technology in 2015. After graduation, she worked as a junior engineer at the Institute of Water Modeling, which is a government trustee of Bangladesh's Ministry of Water Resources. She joined George Mason University for her Ph.D. in Water Resources Engineering in the Civil, Environmental, and Infrastructure Engineering Department in the fall of 2018. She earned her Master of Science in Environmental Engineering from George Mason University in the spring of 2020, and she served as a graduate teaching assistant from fall 2018 to fall 2020. Along with Mason researchers and community leaders, she collaborated in the American Geophysical Union Thriving Earth Exchange Project, initiated by the Northern Virginia Regional Commission to better understand regional vulnerability to extreme hydroclimatic events. She's a graduate research assistant for a NASA-sponsored project. She's investigating projected changes in hydroclimatic extremes using multi-source data sets over high mountain Asia, which will definitely provide critical information for developing resilience and climate adaptation strategies. She received the 2019 National Water Center Innovators Program Summer Institute Fellowship at the University of Alabama, sponsored by the Consortium of Universities in the Advancement of Hydrologic Science. She received the Best Teaching Assistant Award from Civil, Environmental, and Infrastructure Engineering in 2019. And her tentative date of graduation is May 2023. Welcome, Ishrat, sorry.
Thank you, Dr. Henry, for a great presentation. Should I start now, or we have to wait for some time?
You can go ahead, Ishrat.
Okay, sure. Thanks. So let me share my screen. Can you see my screen?
Not yet. It's loading on my end. Okay.
Okay.
Good.
Is it there?
Yes, I can see it. Oh, Sheika is giving hands up.
Okay, thanks. Okay, welcome to my presentation on how our extreme precipitation and the climate crisis. Let's move on. Background is already covered, but I just wanted to highlight that alongside my research, which is mostly on looking at trends of extreme precipitation across different scales, I also did some other research, particularly voluntary research, and I participated in a summer institute program of National Water Centers back in 2019 in Alabama. And then last year, I also joined a field campaign in that's actually looked at soil moisture, validation in Newark in 2022. So I will moving towards my main presentation today. So what do you know about hydroclimatic extremes? So we have seen that global warming induced by anthropogenic climate change that resulted in an intensified hydrological cycle, and that's been provided by several studies and several literature reviews, and some like a rising temperature will create atmosphere to hold large amounts of water that create a condition to more intense precipitation events. And increasing occurrence of these hydroclimatic extremes, such as floods, droughts, are accompanied by this increasing extreme magnitudes over different parts of the world. Exacerbation of these hydroclimatic extremes are most likely to be further intensified, and that it will be really important and it's also essential to look into this changes of these hydroclimatic extremes, because this will bring unprecedented threats to human societies and ecosystem. If we look at the changes in global precipitation, we've seen that from different literatures that the land station dataset shows more areas with significant shift toward wetter conditions compared to areas with toward drier conditions. So if we look at this based on the rainfall estimates of Gridded Network, it's a sets, and that's looked at trends from 1950 to 2016 in annual precipitation. The notable areas with trends toward wetter conditions are in mostly in Eastern North America, Eastern Europe, Asia, and South America. So in this presentation, I would definitely cover the weather extremes because that's mostly my my research is focused on. Let's dive into looked at into the increased precipitation intensity and frequency, and different anthropogenic climate signals are strengthening, and it's gonna be continued at the end of 21st century, and these signals demonstrate a more intense hydroclimatic regime at the end of the century. And the latest assessment report, which is the assessment report 6 from Intergovernmental Panel on Climate Change Assessment, that documents that increasingly intense precipitation over most lands. And this right map is basically from a chapter of this IPCC 6 report that looked at the number of stations from global land stations that and looked at the trends of annual maximum daily precipitation in the earlier decades from 1950 to 2018, and they looked at the increase in increasing trends from those stations, and the percentage of increasing trends in those stations are larger than the percentage of trends in the station that shows decreasing trends in that extreme index. So that's one of the key points to look at into wet extremes in my research. So moving forward, I will be presenting what I picked for my study area and what extreme index I'm looking at. So let's focus on the map for a moment. It shows a map that tells the story of two Americas, one perched and one soaked. And I put the title as it is from recent news from New York Times. While Tennessee is under a flash flood warning, the rest of the country, particularly the West or in California, we've seen prolonged droughts for last 2 decades or so. So this is my study area for this presentation, and I will be looking at over CONUS using new scenario matrix architecture from a climate model and to analyze different extremes indices. I think my screen froze for a while. Let me share it again. Sorry for that. Okay. So can you see it now?
Yes, we can see it.
Sorry for that. Thank you. Okay, moving forward. So why do we need regional studies? We have looked at different, like the previous literatures looked at different precipitation indices, both average and also the extremes at globally. But at regional scale, we might have found different results in terms of trend direction and the strength of changes in terms of magnitude and intensity. And also regional studies are important because we might have seen different trends in different parts of the distribution, say 25th quantile or the 95th quantile, etc. And it's important for regional climate assessment. So now I would like to introduce my research here, what I looked at, which is the projected extreme trends over CONUS. And for this, I used a large ensemble simulations from a single climate model, which is the Community Earth System Model version 2. And I used 2 time windows from 2015 and at the end of 21st century, and from 1950 to 2014. This climate model has 100 kilometer resolution, spatial and daily temporal resolution. I only looked at one shared socioeconomic pathway, which is SSP 370. And the research objective is to how will precipitation change over the contiguous United States at the end of 21st century using a new scenario matrix, which is the SSP 37, and what are the uncertainties associated with those changes. So let me give a brief overview of this large ensemble SSP 370. I have used 70 ensembles for this analysis, and for SSP3, it's actually socioeconomic narratives of the IPCC 6 report, and it says that it represents a regional rivalry, basically a fragmented world of research and nationalism. In simplistic term, it shows like fast growing population and increasing inequalities, which with low international priority for addressing environmental concerns. So it kind of in between mid-emission scenarios and the more pessimistic emission scenarios. So we'll be using that data set, and we'll look at in those. So I already explained, like I used this model. This is a product from NCAR, and I looked at each pixel of the model while I processed my data. I used different extreme indices for this presentation. I'm only showing the seasonal total and also the daily maximum precipitation in each season. And I extract this extreme index for 2 time frame and also for 70 members. So how I produce this trend line or the changes. So these circles represent the extreme indices from each ensemble. So I have 70 ensembles. So basically the 70 ensembles are represented here. And this gives me a distribution. And basically from this distribution, I calculated these different quantiles. So from 25th to 95th. So basically for each year, say this is a seasonal total, and maybe it's spring seasonal total. So the black marker shows basically a quantile, and maybe for this case, it can be, say, 95th quantile. For each year, I have these quantile values, and then I feed a trend line using the Stilson regression technique. And basically that gives me the changes. all the magnitude of trends in different extreme indices. So looking at different results, so this is mostly the seasonal total I'm showing here. I have a bunch of plots, but I will be showing only 2 different extreme indices here. One is this total, and the blue represents the wetting patterns and the red represents the drying patterns. And each row actually will be showing different quantile changes, and column represents different seasons. So in general, basically what you see a spatial pattern that's consistent across different quantile, and also different seasons influence the pattern as well. But I will highlight the main takeaways, or basically the strong signals I see from these plots. So we see almost a drying pattern or a minimal change in the southern parts of the country in spring, and it gets kind of consistent across different quantiles. And then see, in contrast to this part of the country, we see almost a wetting trend that dominates over eastern part and also stretches to the northern Great Plains, and that starts from the quantile 50th, and that stays almost in the summer. We can highlight that the shows a drying, and it is consistent across different quantiles. For these northwestern and southeastern region showing high wetting trends, and also if we go from 25th to 95th. Interesting part is to look at, like, over the central US, we see almost no change, and then it starts to get a wetting pattern at the higher quantile level. For winter, the northeastern side is kind of amplified, or like that. We can see a strong signal in almost all the quantiles here. So this is coming from the seasonal change, or like the seasonal climatology. Then we basically did normalization. What we did, we have the change, and then we normalized it based on our climatological quantiles that we calculated from 1951 to 2014. So we have the same model, and we have a historical time frame. We calculated the quantiles, and we have a climatological quantile for each 4 of these. But I'm only showing for only 50th and 95th. I really want to highlight this 2 part for summer and winter. So we see summer has a higher normalized change over the southern part, like the southern Great Plains and southwestern part, the Konas. And for winter, we see on northeastern and Midwest, and sometimes like northern Great Plains are having higher normalized change in winter. And the error bars represent a standard deviation that exists within a region in those magnitudes of change. Looking into this daily maximum precision, it's the same way I will explain, but I'll be explaining it in terms of different strong signals I see from these plots. So for spring, we see a shift, this extreme wetting trends almost shift towards the northeastern side or the southeastern part, and it actually has a higher wetting trend at the higher quantiles. For summer, we see that, or like mostly the Texas, the wetting trend kind of gradually increased at the higher quantile level. For fall, the central US has almost no change, and then we see a gradual change to wetting pattern. And winter has a similar spatial pattern at spring, but a slight change we can see, like in spring, the northwestern side in the lower quantile, we don't see any kind of change. But winter, we see that the northwestern side, or like the southwestern, is actually a wetting pattern. But that gradually goes to a higher wetting patterns at the end of at higher quantiles. So we did the same analysis, and we have a similar kind of patterns in terms of average change. So we see that southern Great Plains and the southwestern They represent higher normalized change. For winter, the similar northeastern, southeastern, and Midwest. So the differences in these two indices are basically in terms of magnitudes, but the spatial patterns are almost similar. I'm not explaining the spring or fall here, but the spring and winter, we always see a similar spatial pattern. Like we see that even in spring, the higher normal is changing in those same regions like the winter. And also the error bars mostly changes based on the quantiles we used. So in higher quantiles, the error bars are, or the standard deviation are high in general. We also detected uncertainty. So the uncertainty is detected in terms of man-candle test at 5% alpha levels. So basically what we did, for each pixel, we would count the majority vote from 70 ensembles. So say if we have more than 35 ensembles agreeing on a sign of change, then we say it's statistically significant. So it has to be more than 50% ensemble agreement or of a change. For example, no change, or a positive change or a negative change. So for this R1, which represents the daily maximum precipitation in each season, we see that no change agreement over most regions except Midwest and Southeast in spring, and positive change agreement over Northwest in fall and Northeast and Southeast in winter. For the seasonal total, we see a no change agreement in most regions except the Southern Midwest and Northern Great Plains in spring, and we haven't seen any, and all the regions in falls show almost no change agreement. In terms of positive change agreement, we see Northeast, parts of Southeast, Northern Great Plains, and Southwest in winter. I have to share this, that we haven't seen any kind of agreement in negative change based on these 70 ensembles. So that's another highlights from the study. So the take-home messages I have shown from all this analysis is basically we've seen increase in seasonal precipitation in mostly eastern and Midwest corners in spring and winter, while the increase we have seen mostly in summer and fall in Gulf Coast region. In terms of daily maximum precipitation, we have seen that it projects a wetter extreme over most of the regions, particularly wetting in northeastern region in spring and winter, and a relative drying in Midwest in summer in lower quantiles. And summer shows a greater change in southern and western corners. So we published this work in alongside with other my co-authors in Frontiers in Climate last year. So we also looked at the intensity of these extremes. I haven't shown any results from there, but if anyone is interested to learn more about this work, feel free to go to this link. I would like to highlight some of the key features from the study. So we only looked at one climate model with a large ensemble. So that has 70 ensembles. So basically it has 100 ensembles, but we used 70 ensembles during our study period that was available. So that's why I wouldn't say that the study represents the full spread of uncertainties in terms of one single model, and also captured only one specific shared socioeconomic pathway 3, because this large ensemble set has only SSP 370 available currently. And this is not coming from a regional climate model, which is supposed to have higher resolution, and a regional climate model will capture more variation of extremes. And we relied on a prior study that looked at the validation of this model that used global historical climate observation station data. So this map is basically showing the climate vulnerability over different parts of the globe. And this is coming from like a demographic or like socioeconomic model. This is not what I have done, but this is to show or tie up my results with the with moving forward that it's really important to understand these hydroclimatic extremes at different scales so that we can have a better climate adaptation, resilient, and mitigation strategies globally moving forward. And also I would like to highlight or like emphasize on the fact that the seasonal wet and dry extremes might create abundance and or stress in water availability. So basically, it would be really essential. It is essential to study these hydroclimatic extremes at scales. So thanks. And this is my group, and I different experiences on this journey. So thanks all. I would like to take any question if you have.
Thank you so much, Ishrat, for that interesting presentation. So at this time, we would invite the audience to participate. If you have any questions, you can raise your hand or you can type in the chat. Let's see if we have any questions. Okay, so perhaps I can go first, right?
Yeah, sure.
Okay, so I wanted to ask you about the exploratory analysis that you did prior to conducting your research or the analysis. Can you expound on that?
So are you talking about the data processing part or?
Yes, so normally prior to going into the analysis, you would look at, if there are errors in the data or if there are outliers or.
Okay, that's a great question. Thank you for asking it. So like I said, we, excuse me, we did a validation study in a prior study that's not a part of this work, but that looked at continental scale relative change in quantiles. So the study used GACN observation network. And okay, let me go to the slide. Yeah, this one. So the study looked at this GACN observation station data and looked at different relative change in quantiles in historical and also the future precipitation. And basically, if I remember it correctly, I should have actually put that study here. At a continental scale over CONUS, that counted like less than 5% bias in terms of historical simulation and the future projection. Does that answer your question?
Okay, awesome, definitely.
Thank you.
Because I also work with climate data, and I know it's very important. And sometimes there are issues that sometimes researchers don't highlight, because the results are normally highlighted, but there's a huge process that's actually takes place prior to doing the analysis. So I thought that would be relevant to highlight as well.
Yeah, definitely. And another similar study is coming from maybe my group, and another graduate student, she's also looking at the CPC analysis and also this model validation, and that also looked at this large ensemble, is looking at large ensemble distribution and how it captures the variability in terms of different extremes or just the total precipitation.
Okay.
Thanks.
Okay. Awesome. I see someone mentioning something in the chat.
Mm-hmm.
Okay, so this is from Nur. I hope I'm pronouncing your name. Ishrat, thank you for amazing presentation. What is the best strategy to increase the resolution of results that can be used by decision makers?
So definitely it's been there in the literature, like for adaptation and mitigation strategies, we should always have a high resolution, and that's why people are kind of downscaling these GCM projections, and that's called like regional climate modeling. They have high resolutions, but they are really computationally intensive. And that's, even though this results doesn't capture the extremes in terms of magnitudes, the way it should be in a regional climate model, but it gives us an idea about the evolving future in terms of this specific emission scenario. But definitely there have been studies that looked at statistical downscaling, dynamical downscaling of these climate models.
Okay, thank you so much for that. So because we have another presentation, perhaps we can move on to that. Do we have another question before we move on? And if not, we can also come back to Ishrat.
Sure. Thank you. Thank you so much.
Okay, so at this time, I have the pleasure of welcoming Felipe Gomez Gallo. And Felipe is an environmental and civil engineer with a minor in biodiversity and environmental science from Universidad de los Andes. His areas of expertise include meaningful youth engagement, SDGs, engineering education, and climate change mitigation and adaptation. Felipe is also an advocate for mental health and diversity in STEM education, given his journey as a student. He currently holds the Meaningful Youth Engagement Specialist position at the Student Platform for Engineering Education Development, SPEED. He is a member of the Stockholm 50 Youth Task Force and the UNESCO SDG for Youth Network, due to his experience in climate and environmental activism as a member of the youth constituencies of UNEP and UNFCCC. His climate and environmental activism started when he noticed the impacts of the triple planetary crisis in his hometown, using his master's thesis to research climate adaptation strategies. Welcome, Felipe.
Thank you very much for your kind introduction, Dr. Henry. Really grateful for this space. I will be sharing my screen. Give me 1 second. And let me start the presentation. Perfect. I hope you can see my screen, and I will start the presentation. So as Dr. Henry already introduced myself, I'm an environmental and a civil engineer. I'm currently volunteering as a meaningful youth engagement specialist at SPEED, which is the Student Platform for Engineering Education Development. And today I'm going to talk about from local research to global climate activism. So I wanted to start this presentation asking you what to expect from this presentation of today. And I had 2 objectives when I was developing this exercise. The first one is, after doing my research of the Global Science Exchange series that you have had, I wanted to create a presentation that was a bit disruptive. I didn't want to emphasize much on my research, but instead in a history that I wanted to share throughout the presentation. So expect that in the coming slides. But I also wanted you, as a listener, to explore your own pathway to where you are at today. I hope that you can take these couple of minutes that we are going to be sharing at the moment for you to explore how did you get to the place that you are right now. So let's continue. First of all, I have to thank the Climate Reality Leadership course because I will be using a methodology that I learned with the Climate Reality Project. The Climate Reality Project is an initiative that was born by Vice President Al Gore, where he started in his barn with 50 aspiring advocates, using the inconvenient truth to train more people to be advocates for climate action and environmental action. Today, this network is more than 40,000 climate reality leaders across the globe. And the strategy that I will be using today is sharing my climate story. And this all starts with a little kid with 3 years old that was chubby, didn't like to do exercise, and he was a little bit of a nerd. And he grew up in a city that is called Cartagena de Indias. And as you can see, it's a pretty historic and touristic city in my country, Colombia, and it's right next to the Caribbean. It has many challenges, but let me talk about them in a bit. Cartagena is located in the northern part of Colombia, as you can see in this point. We share the Caribbean Sea. We are in the top of the South American continent, sorry. And the weather that you can expect in Cartagena, it's of around 32 degrees Celsius, and that will be in Fahrenheit, like 90 to 100 degrees in a given day. Why is this important and how is that connected with the little kid? Well, I had to do physical education at midday, 12 in the afternoon, running around, sweating my everything because the sun in my city is quite harsh. So that's sparking me the interest of researching how is the sun behavior? Why am I feeling so hard? Why my city has all of these issues? Why is the humidity that high? And that started to spark my interest in climate change research. I also want to show you this little video about the city. And Cartagena, it's all about tourism, decadence, a lot of money, but also the communities that are most vulnerable to climate change. These are difficult spaces because most of the impacts that the climate change is having are mostly affecting these communities that don't have any tools to fight the different challenges. It's quite difficult. Nobody talks about this in my city. It's one of the most unequal cities in my country because, as I told you, we have the most expensive lanyards in the whole country, but also we have a lot of poverty surrounding the city. It's quite a difficult situation. So yeah, keeping this in mind, I was leaving school, starting exploring university choices, and I was really good at math. So in my country, when you are good at math, you are supposed to be an engineer. I faced that decision and I had to pick what I wanted to do. And I found environmental engineering in my journey. And it was a decision that I would regret in the phases of doing my undergraduate, but then I started to appreciate a lot more what I was learning. So as I told you, I was a little bit bored. I felt in a box that if I am an engineer, I have to do certain things. So that was pretty difficult to navigate to on how I could merge my social science interest with the hard topics of engineering. And I decided to do a whole different things during my undergraduate. I started doing student politics. I started to engage with my community. It was really important for me to engage besides the classroom and beside the numbers. So it was a pretty important phase in my life. After being representative, I found a light bulb that ended up changing my whole life at that point. The light bulb refers to SPEED. SPEED is the student platform for engineering education development. And what this is a worldwide nonprofit student organization. And we are striving to connect STEM with 5 pillars of action, which are education, peace, mental health, climate and sustainability, and inclusion, diversity, equity, and access. Those are the most important aspects that we found in our exercise of trying to identify how to move forward with speed. And those are the 5 pillars of action that we are in use in this organization. Our event is called the Global Student Forum, where we gather engineering students from around the globe in a different town in the world. I have been able to participate in Seoul, South Korea, Kuala Lumpur, Malaysia, in Albuquerque, United States of America, Madrid, Spain. And these have opened up my vision of engineering is not just Colombia, but also a global issue that we need to start engaging with a global community. And this was the thing that Speed offered me, a global community where we can identify challenges and provide solutions as engineers. So as I mentioned, the Global Student Forum, it has been all over the place, all over the world. And we are continuing doing these events regularly. What we also always strive to do is community service in the community that we are going. It's not just going there to appropriate of the spaces that we are using, but instead giving back to the community and thanking them for offering us spaces. So in Malaysia, we were able to teach school kids with the projects that we were coming up with. In Lima, Peru, we were able to connect with the local organizers of an event to engage them with the SDGs training. And it has been like that in every GSF that we have had. Now, I would like to emphasize on a research that we did in SPEED. It was called Youth Engagement and Multi-Stakeholder Challenge. And it was developed by Maria Laura Boro Gonzalez and myself. And it was a research on how engineering students and young engineers are often said to be the future of engineering, but instead, why don't we use now to start creating action? The demographics, we identified how many students are out there according to the NSF and how many of them are STEM youth. We're trying to identify as a challenge how to increase youth in engineering. Also identifying the huge gaps on gender for engineering. It's purely dominated by male students and engineers, and we have to do something about it. We also ask a community of practice if the students and the young engineers are truly satisfied with the course of action that they decided to take. And most of the answers that we received were students are certain about what it means to be an engineer. A sizable fraction of engineering graduates consider a future outside of the field of engineering. So they don't find what they were looking for in the engineering tracks, and they look for other ways to engage in their engineering processes. And also, many newly hired engineers do not anticipate the wide range of skills, technical and non-technical, that will be required in the work environment. So we also identified that the UN recognizes that young people are a huge resource to develop and key agents for social change, and participation in decision-making is now a key priority. Largest generation of the young people in history. We are the most connected and the most informed. We are unique and innovative, and we have a multiplier effect. What is the potential to influence engineering education? And it is only by engaging and working with them, supporting them in standing up for their rights and creating the conditions allowing them to progress and play an active role, that the international community will be able to achieve peace, security, justice, climate resilience, and sustainable development for all. So here is like overall identification of values, needs, and aspirations. Diversity, equity, inclusion, and accessibility is a major topic that we deal with when speaking on STEM education, climate advocacy, technological and digital tools, self-care, and set boundaries. So to participate effectively, young people must be given the proper tools, such as information, education about, and to access their receivable rights. So my last of this particular research. What does meaningful engagement actually mean? And there are many how do you say that, significance of meaningful youth engagement, but this is one that I really appreciate. And it is meaningful youth engagement is an inclusive, intentional, mutually respectful partnership between youth and adults whereby power is shared, respective contributions are valued, and young people's ideas, perspectives, skills, and strengths are integrated into the design and delivery of programs, strategies, policies, funding mechanisms, and organizations that affect their lives and their communities, countries, and globally. If you want to continue knowing a bit more on this research, I will encourage you to reach out. I will be happy to share more of the results of this research. So coming back after my research with speed and the nonprofit world, now I wanted to come back to my academic side and use research with my undergraduate and my master's thesis to identify particular topics that were highly important for me specifically. So for my undergraduate, what I did was study the educational curricula of the environmental engineering program at my university and how it was, and answering the question if we were prepared for the challenges that the next 25 years are coming down the line. So what I did was identifying a prospective exercise of finding what will be the biggest challenges that we will have to be facing in the next 25 years. And obviously the main one was climate change and how we as engineers need to be better prepared to attend the multiple crises that are coming our way. And I don't want to be a fatalist, but we need to be prepared in order to take action. For my master's thesis, I did something else that reconnected with what I was doing connecting with my climate story. I wanted to use this tool to truly develop something for my city, for Cartagena de Indias. And what I'm trying to investigate and doing in my research is finding adaptation strategies for coastal zones, and the case studies Cartagena de Indias. This is the first part of my research. We have had a huge crisis with political actors in my city. We had 12 majors in the lapses of just a decade, and that shows how unstable we are in a political situation. Cartagena was identified in 2003 and was one of the most vulnerable cities in my country specifically because of the many nuances of being in Cartagena. And they have just two prepared documentations on adaptation in Cartagena, and that was the only documentation that was in the city created by the district in order to take action in terms of climate related issues. In the state of the art, I tried to identify which were the multiple dimensions of climate change, and it took me a long time to develop this. Afterwards, I have to do an analysis of how all of the multiple dimensions of climate change, how they related to the coastal areas, and then how they interacted with each other. And that's how I came up with this first version of identification of multiple challenges. And I divided them in the sustainable development areas that you are aware of, the social dimension, the environmental dimension, and the economic dimension. And we tried to identify where they were seated in the Venn diagram, but also how they interacted with each other. And one of my hopes when I get my PhD is to try to quantify those links. It's not just finding the links, but how are they quantifiable and how can we create more directed actions to solve those issues identified. So this is a little bit more about my city specifically. This is the most touristic area. The many challenges that we face are open air canals that are attracting vectors all the time, and we have a lot of vector-based diseases in the communities that surround those open channels. Also, we have a huge problem with waste management, and most of the body of water are used as dumpsters in Cartagena, and it is a critical situation because most of our open channels are being contaminated and on the verge of not being able to be remediated. We are also finding erosion in critical areas in our city. This is the church that it's called Cerro de la Popa, and it's a church that is it's worrisome because the erosion is every time more visible in the city. This is also to showcase the waste management problems that we face. This is the plaza in our city, and this is the bay that it's used to for all the dumpsters of the waste. I would also want to show you how my city is affected by floods. Let me lower the volume. This is one of the most critical aspects of the sewage and the poor drainage systems in my city. It doesn't matter if it's raining a lot or if it's raining not as much, you will always find floods in critical areas of my city. This is the city center. As I told you, this is the most touristic place to be in my city. And this is what happens every time that it rains. Let me show you a little bit how they have to improvise, how to mobilize in this flooding, in these flash floodings that we have in the city. Most of the cars also being affected because the seawater and the rainwater, it's a mixture that you have in the terrain, and that affects our cars because most of the mechanics get oxidated. Okay, I don't know how the word is, but the cars are being affected because of the saltiness of the water on the surrounding areas. So yeah, it's a critical situation that we need to address urgently. This is like a overview of the bay and the seawater and the rainwater, how they converge and they affect the roads in my city. So yeah, that's an overview of my research, my first part of my research of my master's investigation, but I haven't been able to continue it because the pandemic hit. And I was trying to do a master's during the pandemic, during so many hardships, family losses, not having a job. It was a difficult time and I had to stop my my research, but I'm hoping to continue it pretty soon. What it's next, what am I missing in the research is I'm doing a toolkit for decision makers to establish how to strategize on the many measures on adaptation that they should achieve in their coastal areas. So we are going to provide a systematic approach on how to prioritize which adaptation should be done now, should be done 2 years, 5 years, etc., etc. Also talking about the pandemic and how difficult it was, during those times in my master's, I was also a graduate teaching assistant. And one of the main concerns that I had with my students was mental health. We were struggling a lot. We were in pretty difficult times. And what I wanted to create with the students was a tool for them to be able to express themselves in all honesty about mental health issues. And then we connect them, the students that we identify as red flags, to the psychology department in my university. It was a really successful exercise. And yeah, also, if you want to know more about the survey that was constructed with a psychiatrist, more than welcome to share that resources. But now, what I wanted to start finishing, wrapping up this presentation, it's all about activism and incidents. Academia can give you a lot of tools for you to learn, for you to grow, for you to take action, but you should also should try to identify every space that you have in order to create incidents in order for you to achieve the greater good. In my case, I'm fighting for environmental action and climate action. So I will showcase right now a short video. This lets me, give me 1 second. A short video of what I have been doing in the past year after I couldn't finish my master's. My master's thesis, I decided to do a lot of activism. And this is a brief video of what I ended up doing last year. Yeah, that was a short video of what I did in the past year instead of finishing my master's thesis. But yeah, these spaces are great. You have a lot of visibility. You can change the world globally in terms that you are most passionate about. In my case, is as I told you, environmental aspects, plastics, climate change, etc., etc. And those spaces, as I mentioned, are really appreciated and you can get a lot of visibility, but they don't get you to change the communities that you would like to change. So what I did after all of these engagements is coming back to my country, and I decided to create the Colombian Platform for Children and Youth. It is a space that gives voices to the always and usually unheard in these incident spaces. And what we are trying to achieve is knocking on doors and let our voice be heard by the people in the decision making. Yeah. So with that, I'm finishing this presentation. I'm really thankful for this opportunity. And as I mentioned just at the beginning of this presentation, I want you to use this opportunity and the minutes that we share together for you to think about your own journey, what inspired you to get where you are today, and how are you trying to change your community surrounding you. So if you want to keep in touch, I leave my email right there and we can communicate later. Thank you very much.
Okay, thank you very much, Felipe, for that interesting presentation. So I see a comment in the chat. The video you had shown, there was no sound. I'm not sure if the sound was required or are you okay? Is it okay?
It was okay. No need for the sound.
Okay, thank you so much. So at this point, I would like to ask the audience if they have any question to ask that at this point. Do we have any questions from the audience? Okay, let's see. Okay, so we have time for one or two questions. All right, so I have a question. In your presentation, you spoke about some of the barriers for, let's say, students, especially females, pursuing like engineering discipline. Can you provide, for instance, your opinion as to what are some of the ways we can overcome that barrier to get more involvement?
Of course. So for women involvement in STEM, one of the first advices that I give is going to the schools, the high schools, showing them that they are able to be on STEM careers. We cannot try to solve this by the university. We need to come back to the roots and showcase these are available opportunities for you to engage. That's the first one. Engage with the little girls that are starting to learn and showcasing career paths that are not used for them. In my country particularly, we suffer a lot from machismo and other ways of blocking processes. So it's an extra layer that we have to face on how to tear down cultural barriers in terms of women's participation in STEM areas. And how we do that, we advocate for them. We are allies. I'm not the voice representing women. I'm just an ally trying to elevate voices of the people that need to be raised.
All right, thank you so much. So at this point, we are out of time. And I just want to use this opportunity to thank everyone for attending, and thank you as well for, participating. So our speakers, thank you very much.